Hi everyone. Today I want to demo uh, one of my uh, uh, one of my project or a product, which I actually did it for AI hackathon, but then I modified and enhanced it to suit our need, and basically which we can try to use for our customer. So this is like a low code platform or a no code platform. You can say like a low no code platform or a low code platform that I have developed. Um, like it is fully configurable. It's called AI Enterprise platform. So which basically we can use to do the first POC or an MVP very quickly for whatever use case that we can get from the customer. So right now, this platform or this project is only to up to a level where we can it can accommodate uh, a less number of data set and less number of documents. But this can be enhanced as like to accommodate a bigger data set, and it can be enhanced it can be scaled up later. But right now, I have made this to a level where we can onboard some of the use case that we get from the customer, mainly conversational chatbot use case that we can get from the customer, and build a POC quickly and show them a demo so that they can get some confidence on that. So let us see this in detail. So I have a admin panel here where you have different agents that's configured here. I have put the agents which are very much common in the projects, and which is very common for any use case, right? So I have configured those kind of agents, and it is sequential right now. It's not parallel. It is a sequential flow, which I have used LangGraph to basically to enable the flow here. I have 7 agents, configurable agents. You can see there is a global system prompt that you can configure first of all. Uh, you can also enable tune, token object notation, token oriented object notation, which is basically to optimize the token that is used by the LLM to optimize the cost. So you can enable in various modules, like you can compress the system prompts, you can compress the user message. So you can enable and disable this. Then you have a human in loop, which will not come into the agent part, but at last you can basically enable this to accept and reject the output produced by the LLM. So other than this, I have 7 agents, in which I have a DB agent where it basically it retrieves the data from the DB. For now, I have used SQLite. Um, then I have a RAG agent where you can vectorize the documents, and this agent basically searches the vectors and brings the required information for the prompt. I have an MCP agent where you can configure the external APIs as MCP tools and provide that to the agent so that the agent can decide to use whenever it is required. I have also a guardrail agent where you can basically configure what kind of guardrails or the security that you need around your bot. I have an observability agent where you can do the tracing and monitoring. I have used Langsmith in the background of observability. Then I have a summarizer agent. So when when the user query passes all these agents, And if DB agent is going to give a subset of data, and RAG is going to give a subset of data, MCP is going to give the data from the external source, then it passes the guardrail and the observability. Then the summarizer agent will basically summarize this answer and provide this to the user. Before providing this to the user, it will basically go to the judge agent, which is LLMS judge. It will basically judge the outcome, and it will provide a confidence score. So how it is working is we'll go into the details one by one. But overall, these are the agents I have, and these are the configurations I have as the agent configuration page. Then we'll go into the RAG. So for the RAG agent to work, we need a RAG database. So I'm using a FAS index database here. So I have we can basically upload the files required to be vectorized directly in the admin panel, and you can basically rebuild the index. So this is also fully configurable. Then if you go to the database configuration, which is important for our database agent, you can basically put a JSON to define the schema, right? Database schema. And you can also provide the synthetic data or user provided data, whatever. Like you can provide the initial data set as JSON. So these are all basically configurable. And once you put it, you can build the database. Then we have the MCP tool. This is a very interesting agent, I would say, apart. And these MCP tools are exposed through an MCP server with the backend, and this can be consumed. This can be consumed as an MCP client. Our MCP agent is consuming this. So you can give a name for the server and the port, and you can add the tool, the required tool, by clicking on Add Tool. You can propose the tool name and the method and description. This description is important. Based on this only, this tool will be picked up by our agent. So which is the endpoint that you wanted to use as a tool, the API endpoint, and then the input parameters that is required for the endpoint. So I have two tools defined here. Which is with these two tools, I'm exposing this as a MCP server to the MCP agent. So you can basically keep adding or deleting the parameters of tools. You can also use the raw JSON format or the visual editor. So then basically you can say save and reload this to restart the MCP server. Then we have the golden dataset part, which will be used by the judge agent to make a LLMS judge. So you can click on update JSON, upload JSON to basically upload a file, or if you have a file, you can just click on edit and you can see the question answer pair. You can add the question answer pair and you can save it. So these all are basically configurable through the admin panel. Now let us see an example. Let us take an example. Now we will go into the demo part of the conversational chatbot. So I have taken an example of a life science case from clinical trial area. So this is a futuristic solution, and it's an imaginary solution. I don't know how much it is feasible to implement this right now. It is about generating synthetic clinical trials. So that's why I'm calling this generative synthetic clinical trial universe. So this is basically you can simulate the clinical trials before actually going into a human-based trial or animal-based trial. You can use this conversational bot to basically simulate uh, the clinical trial n number of times. So what is the main business benefit of this is like you can predict the errors or issues or challenges that you are going to face in your clinical trial basically before going into the actual clinical trial. You can predict this and you can fix this prior, so that lot of investment can be saved. So I have listed the business benefits here. So faster trial development, improved probability of success, reduced patient dropout and protocol risk, stronger competitive positioning, lower compliance and safety risk. I know that according to the compliance wise, this is right now, I don't know how much is possible, but this is a futuristic solution, right? You can think like after some months or days or years. So if at all AI can be also used in this part, where you can make clinical trial simulation and the compliance and the EU Act allows this, then this is a possibility. So then full auditability and transferability. So we have a human in loop. Then this is a confidence-driven solution because we are using LLM stitch. So main business benefit is it will save a lot of money when you're going to simulate the clinical trial. This is what is the use case I have taken to implement the POC with this AI enterprise platform. Okay. So I have some example queries. Let's try that. So I'm saying design a 48-week phase 3 trial for semaglutide glutide in type 2 diabetes. So this is the query I'm going to try. Let's go to our bot. I didn't show you the bot. So this is a basic UI. Right now it's not very fancy. I have it very basic. So you can see all the agent pipeline, how it will flow on the right. So I'm going to put this query, execute this. Let us give it this time. So it basically goes through all the agents and pings as the result. So there is some latency right now, which can be improved. Okay, so we have got the result now. So you can see it has passed through all the DB agent, RAG agent, MCP, Guardrails, observability, and summarizer, and the confidence score. It has also generated a confidence score, 95%, and it is pending for the human review where you can approve, edit, and reject. So I'm going to approve it. You can see like it has given you a study design, inclusion criteria, exclusion criteria, statistic analysis plan, etc. And the LLM has judged that it is 95% accurate. So let's see how basically the flow went through. Go back to this. So you can see how each agent worked. So the DB agent, it has given there was no matching rows, so it returned an empty, no result. Then it went to RAG. It has supplied inclusion and exclusion criteria, endpoints, study design, statistical plan, etc. From the RAG documents. These are the RAG documents that has been referred. Then from the external MCP agent, it has added some external real world validation and context here. Then guardrails have allowed the pipeline to continue because it is inside the keyword set that we have defined. That I forgot to tell you, there is actually, if you go to the Guardrails agent section, you will basically put a system prompt where you will ask, you will put remove the PI data, any patient name, email address, whatever, and also you'll put the scope keywords, uh, uh, which uh, which are allowed, and you can basically put the PI patterns to remove from here. So these are all configurable. Now going back, uh, so our guardrail has allowed, there is no problem here, and the observability agent, it's tracking, basically it's tracking the events. Uh, then the summarizer agent has summarized, the judge agent has given the score. So this is how it has flowed, right? Let me take one more example where we can use more the MCP based query. This is an MCP based query. Let's do this. So find Act 2 Phase 3 semaglutide trials for type 2 diabetes on, I'm mentioning this, cloudtrials.gov. Okay, you bring the information from this website and summarize their status, location, and enrollment. This is what I'm going to give. Okay, let's go here. Uh, let's take a new one. Just refresh this. Let's take a new chat. I'm giving this. So if you go and refer the MCP tools, you can see like I have the endpoints for clinical trial.gov, where I'm having get all studies, and also I have one more tool which is called which can pass the study ID and get the details of that study as well. So the bot is basically going to use these tools. Okay, we have got the answer. Here is a summary. Let us approve this. So here's a summary of the Act 2 Phase 3 semaglutide trial. So it has brought something from clinicaltrial.gov. You can see the key details, interventions. Okay, see, it has used this tool. Please note that the location of this trial are not specified in the summary provided. For more detailed information, you can use a tool with NCDID. Okay. Okay. So I think it has brought the study details, but it is also suggesting to use the tool. I don't know why it didn't automatically use, but that is something maybe it's the model that I have chosen. I've just choose the minimum model right now. So I think if you use a better model, it will automatically go through. But the thing is, it has brought some results from the external website using the MCP server. The answer provides some relevant information but lacks specific details about the trial status, location, and enrollment as requested. So basically, if this tool also got executed, maybe we could have got this answer, a better answer, I think, or better confidence score. But yeah, right now we have got this result through the MCP server. Let me see if I can see the logs here. Yeah, everything is working fine. There's no errors, I think. Okay. So this is what. So let's go and see the flow of this. That will be also interesting. So we have got a final answer, something like this, and confidence score is 60. So the contribution from TP agent confirmed that local database did not contain, because this is an external trial. Okay. Contribution from RAG agent provided general protocol context, but the final answer was primarily driven by cloud trial. Okay. Clinical trial, sorry. So then MCP agent, yeah, this is the main agent that has contributed, provided the core factual content of the answer. So saying it has called the search tool with parameters. These are the parameters that is supplied and returned the live trial data, including the NCT ID. Okay, so this is the major contributor, and Guardrail has allowed this. Tracking has been done, and Summarizer has summarized this, and Surge Agent has scored this as 60%. Yeah. So this is how it has flowed, and it is all the agents are working perfectly. And trust me, I have not done any code changes for this. I've done I've implemented this use case fully with configuration, only with configuration. Yeah. So this is what I wanted to convey. I also wanted to show you the traceability and observability part using Langsmith. So this can be also enabled and disabled. That if you want the traceability, you can switch it on, or if you don't want the traceability, you can switch it off. So you can basically see the conversation or the different agents that it has went through. It has also used tune wrapped LLM. So and what kind of models it's used. So what is the query? What is the thinking? You can see that it is trying to use the MCP tool. So all kind of tracing you can see here. And also I want to one more thing I want to mention is we have a .env file here, which I cannot show here because there are some confidential informations. But I wanted to mention some of the features that I have on env file is you can either mention the LLM through Bedrock, or if you want to bring in some other API based LLM. So if you want to put the LLM endpoint, you can also do this. So it is switchable. There is a configurable flag that you can configure whether the agent or whether the agents needs to use the Bedrock based LLM or the API based LLM. So both the libraries are configured here. Both the SDKs are being used here. Bedrock based SDKs or for the endpoint based LLM, I'm using Langchain based OpenAI chat SDK here. So it can be switched easily. So you can basically configure these endpoints into the .env file, and you can easily switch it. So these are all some of the features additionally I have on the configuration or we can say the environment variables files. So that's what I wanted to convey. So this is all for the demo I wanted to convey. Thank you for listening to me patiently, and we'll meet you soon. Thank you everyone.